In 2019, scientists walked into a riverbed in Transylvania and found bones stacked on top of bones. Black dinosaur skeletons gleaming in gray clay, more than 800 fossils recovered from an area smaller than your living room. Something had turned this place into an ancient graveyard, and whatever mechanism created it was so efficient at concentrating death that it left the bones intact. This wasn't a massacre, it was a machine. The Hațeg Basin in Romania has been famous for a century. It is one of the most important dinosaur sites in Europe. Paleontologists have scoured these hills for generations, uncovering scattered remains of dwarf dinosaurs that lived on an ancient island ecosystem that existed 72 million years ago. The basin is known for its slow, careful excavations. Most sites yield 1 or 2 significant finds per season. But even in a place this rich with history, what happened in 2019 was unprecedented. The Valera Dinosaur Research Group, a team of Hungarian and Romanian paleontologists led by Gabor Botfalvai from Eötvös Loránd University, was conducting their very first field survey in the western part of the basin. They weren't expecting to find much on day one. Most fossil hunting is measured in days of walking for mere seconds of discovery. You scan hillsides, you inspect erosion channels, you walk stream beds hopping for a single weathered fragment. But this was different. Almost immediately, within the first hour of their survey, they walked into a ravine and saw something that changed everything. Dozens of bones, large ones, black mineralized fossils gleaming against the dull gray clay of the streambed. They weren't hidden beneath layers of sediment, they were exposed, eroding out of the earth, practically begging to be found. It was a defining moment. In paleontology, you usually find a bone, maybe 2 if fortune smiles on you. Finding 5 in a day is cause for celebration. Here, the ground was densely packed with them. The surface looked like a cobblestone street made of dinosaur remains. They named the site K2, and as they began to brush away the dirt, they realized they weren't looking at a normal fossil site. They were looking at a mass grave. To understand why K2 is so shocking, you have to understand the mathematics and statistics of fossil hunting. In a typical rich dinosaur site, one that paleontologists would consider exceptional, you might find 1 or 2 bones per square meter. Maybe 5 if you're incredibly lucky and working in a known bone bed. Even the famous sites are sparse when you measure density. It is scattered, patchy. You dig for days, sometimes weeks, to find a single significant specimen worth preserving. At K2, the normal rules of probability and distribution didn't apply. The site seemed to violate every expectation. The researchers documented more than 100 vertebrate fossils per square meter. In an excavation area measuring less than 5 square meters, they recovered over 800 distinct fossils. It is the richest site ever documented in the Hațeg Basin, and one of the densest accumulations of vertebrate remains in the entire late Cretaceous of Europe. The bones weren't just close. They were lying directly on top of one another, a chaotic, jumbled pile of death. There was no sediment separating them, no time accumulating between them. Whatever happened here didn't happen over thousands of years. It happened fast, and it affected everything. And the preservation was exceptional. Usually when you find this many bones piled together in high concentration, they are broken, crushed by the weight of overlying sediment, fragmented by the hydraulic forces that brought them there, trampled by scavengers, weathered by exposure. But these bones were pristine, intact, black and shiny and perfect, as if they had been carefully placed rather than violently deposited. It was a paradox that demanded explanation. The site was violent enough to pile them up in unnatural density, yet somehow gentle enough to keep them whole. So who died at K2? The answer is everyone. This wasn't a selective trap that caught just one species or one size class. It wasn't specialized for large animals or small ones. It captured an entire cross-section of the ecosystem, from the smallest to the largest, from herbivores to carnivores. The most common victims were dinosaurs from the Rhabdodontid family. These were plant eaters, roughly 2 meters long from snout to tail, walking mainly on 2 legs when moving quickly. They were the sheep of the Cretaceous Hațeg Island ecosystem. Common, numerous, abundant in the fossil record, and at K2 they are found in droves, representing the baseline fauna of the region. But mixed in with the commoners was royalty. The researchers identified remains of a titanosaurian sauropod, a long-necked giant that would have towered over the landscape. In the Hațeg Basin, titanosaurs are known mostly from isolated bones scattered across multiple sites, a femur here, a vertebra there, a rib fragment weathering out of a hillside. Finding associated skeletons, bones from a single individual that stayed together, is almost unheard of. But K2 yielded multiple partial skeletons that remained associated with one another even after 72 million years. It is the first time a well-preserved sauropod skeleton has been found in this part of Transylvania, making K2 not just a quantity discovery, but a quality breakthrough. And it didn't stop at dinosaurs. The gray clay held the remains of amphibians, turtles, crocodiles with teeth designed for crushing, flying reptiles, pterosaurs whose hollow bones are notoriously fragile and rarely preserved, even tiny, delicate mammals, creatures whose fossils are so rare in this time period that each new specimen is a major event. It was a complete inventory of life 72 million years ago: predators and prey, land dwellers and water dwellers, giants and dwarfs. Residents of the forest and residents of the streams all ended up in the same 5 square meter patch of mud. The fact that partial skeletons remained associated, meaning the bones of a single animal stayed close to each other, is a critical clue. It means these weren't skeletons that had weathered out of a hillside and washed down a river for miles, falling apart along the way. These animals arrived at K2 relatively intact. They arrived as bodies, not just bones. 72 million years ago, this region wasn't a temperate forest like it is today. It was a warm, subtropical island surrounded by ancient seas. The climate was seasonal, marked by violent weather patterns that would arrive without warning. Temporary river systems flowed from higher terrain down toward the basin, carving channels that existed for months and then dried up completely. And when the seasonal rains came, they didn't just water the land, they drowned it. Flash floods were a regular feature of the landscape, reshaping the terrain every year. The research team, including co-author Soma Budai from the University of Pavia, reconstructed the crime scene. Detailed study of the rocks indicates that K2 wasn't a river channel itself. It was a small lake, a quiet standing body of water, but it was fed by flash floods, violent surges of water that tore through the landscape, gathering everything in their path. Imagine a flash flood roaring downstream at speeds that can exceed 30 kilometers per hour. It picks up animal carcasses from the surface as it goes. Creatures that died of natural causes days or weeks earlier, animals that drowned in the rising waters, bodies lying on riverbanks. It carries them, tumbling and rolling them along the bottom until the river hits the standing water of the lake. The flow velocity drops to zero almost instantly. The energy is gone, the water spreads out. And the river drops its load of cargo right there at the interface, piling it up in the deltaic fan. The bodies accumulated in the deltaic environment along the shore, layer upon layer, flood after flood, season after season. It functioned like a hydraulic trap, but one driven by physics rather than chemistry, not sticky like tar, but just as effective at concentrating death in one small area. The water did the sorting. It gathered the dead from miles around, from higher elevations, from tributary streams, from floodplains, and deposited them in this one specific pocket of wetlands. It created a bone concentration that seems impossible until you understand the physics of moving water and sediment transport. It is reminiscent of the famous La Brea tar pits, but the mechanism is the inverse. In tar pits, the trap kills the living. At K2, the water collected the dead. But the result is the same, a density of fossils that provides an unprecedented look at a specific moment in time. The density is impressive, but Zoltan Sisiki-Sava, the Romanian leader of the research team, points out something even more important: age. The K2 site represents the oldest known vertebrate accumulation in the Hațeg Basin. This isn't just another snapshot, it is the first snapshot. By studying this assemblage, scientists can look into the earliest composition of the dinosaur fauna on this ancient island. It allows them to trace the evolutionary directions these lineages were taking, to see where these animals came from and what they were becoming, to understand which traits were stable and which were changing. It provides the baseline. Without K2, we are reading the book of late Cretaceous Europe starting from Chapter 3. K2 gives us Chapter 1, the opening snapshot of how this ecosystem was structured at the beginning of its final chapter. This discovery helps reconstruct dinosaur life across ancient Europe during a critical period. The late Cretaceous was the final act of the dinosaur story, spanning millions of years before the asteroid impact that ended their reign. Understanding how these ecosystems formed, how they functioned, and how they changed in the millions of years leading up to that final event is crucial to understanding extinction itself. Were they healthy and thriving? Were they already in decline, struggling with environmental stress? K2 suggests a vibrant, diverse, densely populated world still operating at full capacity. It reveals how these communities were structured before the end. It shows us that the dwarf dinosaur phenomenon, where isolated island species evolve smaller body sizes, was already well established 72 million years ago. The ecosystem was stable enough to support large populations of these animals and the predators that hunted them. The publication in PLOS 1 is just the beginning of this story. The real work is happening now in laboratories in Hungary and Romania, where specialists are analyzing every fragment. The titanosaur skeletons are the immediate priority. Because they are the first well-preserved specimens of their kind in the region, they hold the key to placing the Transylvanian sauropods into the broader evolutionary family tree and understanding their relationship to giants found elsewhere. Are they closely related to giants from other parts of Europe? Or did they evolve in isolation for millions of years, developing unique traits found nowhere else? The bones from K2 will answer that. Every fracture, every muscle attachment site, every growth ring is being mapped with precision. The analysis is ongoing, and the team expects it to rewrite the taxonomy of these long-necked giants and potentially reveal entirely new species that have been hiding in plain sight. And they are still digging. The site hasn't been exhausted, far from it. Remember, 800 fossils came from less than 5 square meters of excavated surface, but the bone layer continues into the hillside, extending laterally and vertically into unexplored territory. Every field season brings more material to the surface. More pieces of the puzzle, more questions, more answers. There is always the potential for something entirely new lurking beneath the surface. A new species of predator no one has documented yet. A new type of bird-like dinosaur. A mammal lineage that changes our understanding of early mammal evolution. The exceptional density of the site means the probability of finding rare, delicate fossils, the kind that almost never preserve, is higher here than anywhere else in the basin. K2 is a treasure chest that they have only just cracked open, and the contents may take decades to fully catalog. It is easy to look at a pile of bones and imagine a catastrophe, a mass death event, a herd drowning together in a single storm, an entire population wiped out in one tragic moment. But the reality of K2 is more subtle and perhaps more fascinating than simple catastrophe. It wasn't a single bad day, it wasn't one flood, it was a process. A hydraulic concentrator operating over centuries or potentially even millennia, gathering the dead from across the landscape and storing them in one geological archive. These animals didn't necessarily die together in the same event. They died in different places at different times under different circumstances. A rhabdodontid that died of old age on a hillside 5 kilometers away. A titanosaur that fell ill near a stream and collapsed where it stood. A turtle taken by a predator along a riverbank. The floodwaters were just the transport mechanism, the delivery system. Nature's sorting machine, gathering specimens from across the drainage basin and concentrating them in one spot where preservation conditions were optimal. This site is a testament to the random, chaotic forces that create the fossil record we study today. We often think of fossils as snapshots of life, frozen moments of animals going about their daily existence. But K2 is something different. It is a snapshot of death, curated by water and physics. It gathered the pieces of a complex world and stored them in a safe deposit box of clay, waiting for 72 million years to be opened by a team of paleontologists walking through a Romanian streambed. It reminds us that for every fossil we find and catalog and study, millions of others were lost forever. Ground to dust by geological forces, washed away by erosion, consumed by scavengers, oxidized by exposure to air. K2 is the exception to the rule, the anomaly, the place where the physics of the planet conspired with the chemistry of preservation to save the biology of the past. And now, because of 5 years of careful excavation, we can read that archive. 5 square meters, 800 fossils. The richest vertebrate accumulation ever documented in the Hațeg Basin and one of the densest concentrations of late Cretaceous remains in all of Europe. It started with a gleam of black bone in gray clay on a summer afternoon in 2019, and it has ended up redefining our understanding of late Cretaceous Europe and how island ecosystems functioned in the final age of the dinosaurs. The K2 site proves that even in regions studied for 100 years, regions where generations of scientists have walked the same hills and scanned the same outcrops, the biggest discoveries can still be waiting right under our feet. You just have to know where to look. And sometimes, you have to get lucky enough to walk into the right riverbed at the right moment and notice the gleam of black bone against gray clay. If you want to keep exploring the hidden history of our planet, make sure you are subscribed. We are digging up new stories every week. Thanks for watching.